Brad Williams, Frugal Finance, the seasonal swap. In a seasonal swap, the notional principal varies according to fixed plan. This kind of swap can be useful in matching the financing needs of retailers. For example, the swap could be structured on a seasonal basis to match the typical heavy fourth quarter needs of retailing firms. When the notional principal on the swap first increases and then amortizes to zero over the life of the swap is called a roller coaster swap. Thus, the notional principal can be structured to conform to the notional principle of risk management needed. The seasonal swap could be synthesized by a 6-bond portfolio. The resulting seasonal swap previously explored had quarterly payments in February, May, August, and November. The notional principal was $10 million for payments in February, May, and August, and $30 million for the November payment. The swap had a tenure of 7 years. Pricing the swap uses the same technology that we've explored for plain vanilla swaps. That is, we need to find the SFR that equates the present value of the floating rate in fixed rate cash flows. However, we must take into account of the varying notional principal. We can allow the notional principal to vary by including a different potential notional principal in each element of equation 1215. SFR, I think we got a summation of n being the notional principal for the nth time period, plus the FRA, looks like we're looking for the 0 times MON divided by the same structural layout. Equation 22.16 SFR is equal to, looks like notional principal times FRA. We have the notional principal twice, it looks like, times Z divided by E. All right, doesn't that look elegant? The only difference between equation 22.15 for the SFR of a plain vanilla swap and equation 22.16 for the SFR on a seasonal swap is the inclusion of a varying, that'd be this N of P right here, this varying notional principal when the notional principal is constant in all periods. We can use equation 2216 to price our seasonal swap. Figure 22.14, not shown, shows the gentle rising term structure over the 28 quarters that comprise the tenure of the seasonal swap. I didn't think it was that important. The yields to the right are par yields. As our swap has quarterly payments, we must take account of quarterly compounding. As our swap has quarterly payments, we must take account of quarterly compounding. Table 22.9 presents information on the term structure environment and the cash flows on this seasonal swap. The second column shows the annualized par yields, while the third column shows the notional principal for each of the 28 quarterly periods covered by the swap. Column 4 through 6 show the quarterly par yields, the zero coupon factor for each quarter, and the forward rate for each quarter. Here, here, and here. The quarterly par yield is just the annualized par yield divided by 4. The zero coupon factors were found by the bootstrapping method, and the forward rate factors were computed from the zero coupon factors. C36, which is this part, and we're just going to divide by 4. We have a zero coupon factor, and we took 101.5 divided by 100. Then we're going to go down, and we're going to do this long and cumbersome task of computing. Here's your zero coupon factor, all right? I computed it. Then the forward rate factor, oh, I bet you we have a space there. That's going to be equals F36. F36 divided by 37 by 36. A present value of floating payments, D36, 10 million, times G36, your forward rate factor, minus 1 divided by F36. That's the present value of floating payments. And then value of notional principal divided by the zero coupon factor. D36 divided by F36 gives you 985217. We look here, our SFR quarterly, our swap rate is 1.8662. That's H64. sum of H36, 63, divided by I, 64. Annualize, we're just taking this times 4. To complete the calculation of the SFR and the swap, we need to find the present value of the floating rate cash flows, the numerator of equation 2216, and the present value of the notional principals, the denominator of equation 2216. In both the numerator and denominator of equation 2216, there will be one term corresponding to each period of the swap. As an example, we show how the numerator and denominator elements for the 15th period were found. The notional principal for period 15 is 10 million. The forward rate for the period is 0.17726, 0.1017726, and the zero coupon factor is 1.288071 right here. Therefore, the corresponding element from the present value of the floating cash flow in the numerator is 10 million times 0.017726 divided by 1.288 equals 13617. The value appears along with the 27 other present values in the 7th column of table 22.9. The present value of the 15th notional principal is as follows. 10 million divided by 1.28 equals 7773547. The element appears in the last column in 22.9. The sum of the present value of all the floating payments is shown at the bottom of column 7 in the table, as I've shown, and equals 6,103,881. This is the value of the numerator of equation 2216 as applied to our seasonal swap. The sum of the present value of all the notional principals appears at the bottom of column 8 and equals 327,085,139. We got a little bit of a difference here. I'm not going to make a big deal out of $9. This is the value of denominator of equation 2216. Given this information, the swap fixed rate on a quarterly basis is as follows. SFR 16.1 million divided by 327 million equals 0.01866144 equals 1.87. The annualized term is the SFR 0.74646 equals 4 times 0.187 equals 746. Got it? So in a nutshell, we packaged all that nasty bootstrapping information, all the forward rate information, all that present value information, and then the value of the notional principal in this nice little box here, as opposed to 16 columns and 150 rows to produce an SFR. All right, this is much cleaner. Whatever works for you, works for you. Brad Williams, Frugal Finance. Thanks for watching. See you soon.